Hello and welcome students to Make Pro Classes, my official YouTube channel. Myself Piraj Mojumdar, Assistant Professor of Mechanical Engineering Department, GKCM, that is Greater Kolkata College of Engineering and Management under JIS Group. Welcome you to our new session of Advanced Welding Technology, where we will be uploading all the lecture series according to MacOut syllabus day by day. So keep in touch with us for getting daily updates. You can also contact me through 9433465217, that is my personal phone number, or even you can email me at pirasar@gmail.com. You can also connect me through social networking, that is Facebook page, which is known as Make Pro Classes. So let us start today's online session. Previously we have discussed some of the effects of the different process parameters and the characteristics of weldments. Now today we will be discussing the second part of this particular effect of different process parameters on the characteristics of weldment. So let us begin today's class. So today we will be discussing effect of GTAW process parameters on weld bed geometry of AA7075T6 weldments. Gas tungsten arc welding is mainly the characteristics by the weld pool geometry. This is the weld pool geometry plays an important role in determining the physical properties of the weld. Now, the selection of process parameters for obtaining optimal weld pool geometry in the AC pulse GTAW of A7075T6 aluminum alloy is being analyzed. The traditional Taguchi method is widely used for optimizing the process parameters of a single response problem. Optimization of a single response results the non-optimum values of for remaining purposes. So we have this this thing. So see, optimization of a single response results the non-optimum values for remaining responses, but the performance of the manufactured products is often evaluated by several quality characteristics. Under such circumstances, multi-characteristics response optimization may be the solution to optimize multi-responses simultaneously. So, multi-characteristics response optimization model based on Taguchi and utility concept is used to optimize GTAW process parameters such as peak current, base current, frequency, pulse on time, gas flow rate, and welding speed on multiple performance characteristics, namely weld pool geometry, and characteristics such as penetration, face width, and back width. So Taguchi's orthogonal array was selected for experimental planning. The experimental result analysis showed that the combination of higher levels of peak current, base current, gas flow rate, and lower level of welding speed and intermediate level of pulse on time and frequency is essential to achieve simultaneous maximization of penetration and minimization of face width and back width. The ANOVA is next used to analyze the results further. So coming to the this in manufacturing, quality is the measure of fineness or a state of being free from defects, deficiencies, and significant variations. So weld quality mainly depend in the field of welding. This weld quality mainly depends in the field of welding depends on the mechanical properties of the weld metal zone, that is the WZ, and the heat affected zone, that is the HAZ, which consecutively is influenced by metallurgical uniqueness and chemical compositions of the weld. Furthermore, these mechanical and metallurgical features of the weldment depend on the weld bed geometry, which are directly related to welding process parameters. In other terminology, weld quality depends on welding process parameters. Uh, this Evolutionary algorithms and computational network are widely used nowadays to develop mathematical relationship between the welding process parameters, input parameters, and the output variables of the weld zone as well. Now, the main weld bead geometry variables are heat affected zone, bead width, bead height, penetration, and area of penetration. These are greatly influenced by welding process parameters, welding speed, welding current, shielding gas flow rate, and gap distance. It is necessary to find an optimal GTAW process condition capable of producing desired weld quality. In the present study, optimization was performed in such a way that all the objectives should fulfill simultaneously. Such an optimization technique is called multi-response optimization. Now, in this GTAW, a non-consumable tungsten electrode shielded by inert gas is used to strike an electric arc with the base metal. The heat generated by the electric arc is used to melt and join the base metal. The traveling speed of the electrode is controlled by a DC motor. Filler were pre-placed in the groove of 30 degree and root gap of 2 millimeter. In the experiments, the welding power source is provided by GTAW welding machine Master TIG MLS 303 3003 ACDC. The shielding gas is 99.99% argon and the flow rate of the shielding gas is controlled by a valve meter. The base metal is AA7075 T6 aluminum alloy plates. A single pass welding process is performed because the thickness of AA7075 T6 aluminum alloy plates is 3.46 millimeter. So, the base metal used in this study was AA7075 T6. It is in the form rolled sheet of thickness 3.46 millimeter. The welding of AA7075 T6 usually involves using a non-heat treatable filler material such as ER5356 to increase the hot cracking resistance of the old fusion zone. So in this study, selected a commercially available filler ware, that is ER5356. The chemical composition of both base metal and filler were measured by the method is of spectrospark emission using a spark analyzer, and the working range of peak current IP, base current IB, welding speed S, frequency F, pulse on time PON, and gas flow rate GF has been explored by inspecting bead appearance, bead contour, and for any visual defects. The working range of the process parameters IP, that is the peak current, was around level 1 was 195, whereas level 2 is 200, and for level 3 it was 205. Now, if you go through the analysis, you will find that a lot of effect have been created by the change in the different welding parameters as well. So, first of all, let us discuss about the this wait a second, effect of penetration. So the penetration was considered as the quality characteristics with the concept of the larger the better. The analysis was made using the popular software specifically used for design of experiment applications known as Minitab 15. The average values of penetration for each parameters at level 1, 2 and 3 for raw data are plotted. From the figure, it is very clear that Peak current, IP, frequency F, and pulse on time are the most significant process parameters compared to other process parameters. Now the figure shows that as the increase in peak current up to 200 ampere, the penetration value decreases and penetration value increases with further increase in IP value. This is because at low IP up to 200 ampere, the heat input is less and it is not sufficient to melt base metal with the filler material. The peak current more than 200 ampere gives more heat and it melts the base metal with filler material completely and gives full penetration. So peak current plays an important role in the determination of penetration value. As the base current increases the up to 98 ampere, the penetration value go on increasing, and after 98 ampere the further increase in IV value, there is decrease in penetration value. Now as the base current increases, the higher the as the base current increases, higher the value of penetration. This is because the IV is mainly helpful in maintaining continuous arc during welding, so it melts more base metal and filler material in narrow direction, so penetration increases. Now process parameter not as significant as other. As the welding speed decreases, the penetration value go on increasing. This is mainly because lesser the speed, complete melting of submerged filler metal and base metal leads to complete diffusion of filler metal into base metal and forms a perfect joint. As the frequency increases, penetration go on increasing for part diffusion of filler metal into the base metal, so the penetration value increases, but further increase in the F from 6 Hz, more penetration than required leads to undercut and decrease in penetration value. Now the percentage of contribution, that is non-significant process parameters for penetration. As penetration is the higher, the better type quality characteristic. Now it can be seen the optional GTAW process parameters for maximum penetration are IP 205 ampere, IP 103 ampere, speed is 200 millimeter per minute, frequency is 6 Hz. Now coming to the effect on phase width. The phase width was considered as the quality characteristics with the concept of the smaller the better. The average values of phase width for each parameter at levels 1, 2 and 3 for raw data are plotted. From this, the peak current, welding speed, pulse on time and gas flow rate are the most significant process parameters compared to the other process parameters. Now it shows the increase in peak current up to 200 ampere, the phase width value decreases and phase width value increases with further increase in IP value. This is because at low IP up to 200 ampere, the heat input is less and it is not sufficient to melt base metal with the filler material. The peak current more than 200 ampere gives more heat and it melts the base metal with filler metal completely and increases phase width. So peak current play an important role in the determination of phase width value. As the base current increases the up to 98 ampere, the phase width value go on increasing, and after 98 ampere further increase in IV value, there is decrease in phase width value. As the base current increases, higher the value of phase width. So this is because IV is mainly helpful in maintaining constant continuous arc during welding. So it melts more base metal and filler material in narrow direction, so phase width increases. On the other hand, frequency increases, phase width go on decreasing. This is because more pulse rate and more heat contact in narrow direction. So now coming to the effect on back width. The back width was considered as the quality characteristics with the concept of the smaller the better. The average values of back width for each parameter at levels 1 to 3 for raw data and SN data are plotted. And from the diagram, it clearly says that peak current, welding speed, pulse on time are the most significant process parameters compared to the other process parameters. Now an increase in peak current up to 200 ampere, the back width C value decreases and back with the increase in IP value. So this is because at low IP up to 200 ampere, the heat input is less and it is not sufficient to melt the metal to reach the root. The peak current more than 200 ampere gives more heat and it melts the base metal with filler metal completely and reach the root with more back width. So peak current plays an important role in the determination of back width value. As the base current increases up to 98 ampere, the back width C value go on increasing, and after 98 ampere further increase in IV value, there is decrease in back width value. As the base current increases higher, the value of back width. This is because IV is mainly helpful in maintaining continuous arc during welding. So it melts more base metal and filler metals towards the root, so back width seed increases. Now as the higher welding speed laser the time for the contact between arc and base material with submerged filler material, this leads to laser back width. Now the decrease in welding speed increases the back width. This is because more time for contact between arc and face of base metal with submerged filler material. So as the frequency increases, back width go on decreasing. This is because more pulse rate and more heat contact in narrow direction. So multi-response optimization using Taguchi and utility concept, and its confirmation was given. Now it gives you that on the basis of Taguchi approach and utility concept, a model was developed to attain this. The L27 OA was used for experimental planning. In multi-response, the analysis of means establishes that a combination of higher levels of peak current, base current, and this gas flow rate and lower level of welding speed and intermediate level of pulse on time and frequency is essential to achieve simultaneous maximization of penetration and minimization of face width and back width. The significant and percent contribution is of the process parameters are multiple performance, that is the frequency is the most essential parameter, and also it is found that interactions, especially IP into IB into S, are most significant in determining utility values. So interaction consideration is most effective in analysis. The validation experiment confirmed that the adequacy of utility value model is justified. It is found that the proposed model based on Taguchi approach and utility concept is useful and provides an improved solution for multi-response optimization. So you can see so we have these process parameters for welding. That if you consider this one, diameter of wire is taken as around 1.2 millimeter value, and standard current is around 220 ampere, voltage is 24 volt, and shielding gas argon and carbon dioxide. Kind of tested microjet cooling gas is argon and helium. Gas pressure is 0.4 megapascal, and couple of jets, first 40 micrometer and second 50 micrometer. Gas in injector always the same for two jets. Now filler wire is ER4043, wire diameter is 0.89 millimeter. Laser power is 2.5 to 4 kilowatt. Welding speed is 1.5 to 2.5. Laser wire distance is 1, 2, 3 and 5 millimeter. Process ordering laser leading. Wire feed speed is 7 meter per minute. Shielding gas is argon and shielding gas flow rate is 20 liter per minute. Welding speed is 7 millimeter per second. Wire feeding rate is 7 meter per minute. EP-EN balance is -5. Shielding gas flow rate is 21. Torch angle is 55. Wire extensions is 12. Striking current is 115%. Termination current is 45. Now considering the test case A, work thickness is 6 millimeter, welding current is 140 ampere, arc voltage is 23.5, flow rate of plasma is 22.5 liter per minute, And for test case B, we have this work thickness as 8 millimeter, welding current as 180 ampere, arc voltage as 26.5, and flow rate of plasma gas is 3.5 liter per minute. Other parameters are welding speed as to 120 millimeter per minute, flow rate of shielding gas is 15 liter per minute, standoff distance is 5 millimeter, orifice diameter is 3.8 millimeter. So here you will find another different classification of the welding parameters: electrode types, process, gas, voltage, wear feed, speed, deposition, total weld time, etc. So for their different processes, they are having this different types of gas used, as well as the voltage, as well as the wear feed speed, as well as the deposition, and the total weld time also is different. Now these are the again trial current, voltage, welding speed, how the welding travel speed is being varied by varying this heat input can be varied by the varying of travel weld speed. So that's all for the welding parameters, the effects of the welding parameters. Thank you for watching.